let's review, before we get into horizontal asymptotes, let's review what we've done so far. When we are discovering all of our properties of a rational function, the very first thing we always need to do is what? Factor. Very good. Your first step always should be to factor. Okay? Always start off by factoring the numerator and the denominator. Because then, by doing that, you can do one of the first things we've learned, and that's identify holes in vertical asymptotes. So the first thing would be, is there any holes or vertical asymptotes? And how did we find holes in vertical asymptotes? Do you remember? You set the bottom equal to 0. You set the bottom equal to 0 because that'll tell you where it's undefined. You can never have 0 in the bottom of the fraction. If you have 0 in the bottom of the fraction, it's undefined, and it's undefined because that is where a hole or a vertical asymptote is. A hole being something, remember, that crosses off on top and bottom. Okay. Then, once we knew vertical asymptote and holes, we can then identify the domain. Whatever the hole and vertical asymptote are, the domain cannot be that. So we say x cannot be whatever the vertical asymptote and or hole is. Okay, they kind of go together. They're always opposite of each other. Okay. Then we got into x-intercepts and y-intercept. Remember how to find an x-intercept? X-intercept is when y is 0. The only way to make a fraction equal 0 is what? If the 0 is on top. If you've taken 0 divided by something, it's 0. So to find x-intercepts, you set the top equal to 0. Okay. How about y-intercept? How do you find y-intercepts? You're going to sub 0 in for x and solve. Because a y-intercept is when x is 0. So then we have the new part today. 5 and 6 is going to be my horizontal asymptote, and 6 is going to be then my range. Okay? So we got to go over horizontal asymptote here. And I have an acronym for that. You can write this acronym in your notes, and I'll explain what it means. It's this. Bobo. Can you guys read that? Botten. Here, I can write it over here. There's your acronym to remember horizontal asymptotes. Bobo-Botten eats DC. Okay. So what does that mean? Well, let me erase some of this. Everyone has that written down, right? Okay. So horizontal asymptotes. First thing we need to talk about with horizontal asymptotes to understand this is, do you guys remember what the degree of a polynomial is? So if I had some polynomials written here, okay, the degree of a polynomial, if you remember, is the highest power in that polynomial. So the degree of this polynomial is 2. The degree of this polynomial is 1. And the degree of this polynomial is 3. The highest power that you see in that polynomial is called the degree of the polynomial. That's why we say this is cubic, this is quadratic, this is linear, because that degree names the polynomial. Okay? So you need to know the degree of the polynomial. The other thing you need to know is the leading coefficient. The leading coefficient of a polynomial is the number that leads the polynomial. So 2, see how it's leading it? 2 is called the leading coefficient. 2 would be the leading coefficient. 3 would be the leading coefficient. What about this one? What's the leading coefficient? 1. There's a 1 there, and that 1 would be the leading coefficient. Okay? So after you know what leading coefficient and degree is, this is what your rules are. Okay? If the degree on top, no, let's do bottom. If the degree on bottom is bigger, it's 0. Right? If the degree of the polynomial is bigger on bottom, your horizontal asymptote is 0. So example, if I had x plus 4 over x squared minus 2, see how this is 1 and this is 2, and it's bigger on bottom, I would say my horizontal asymptote is 0. Okay? Or if I had 7 over x plus 1, this is a degree of 0 because there isn't an x, and this is a degree of 1. So which is bigger? 1 is bigger than 0. So again, I'd say my horizontal asymptote is 0. Okay? Whenever the degree is bigger on bottom, your horizontal asymptote is 0. And that's what this stands for here. Bobo, bigger on bottom, we say y equals 0. Bobo, bigger on bottom, 0. Okay. So what's the next one? Botan, maybe you can guess. If it's bigger on top, it's none. You don't have one. Okay. So what does that mean, bigger on top? If I had 3x squared plus 4 over x minus 5, the top has a degree of 2, the bottom has a degree of 1. It's bigger on top. Or if I had x cubed minus 5x over x squared minus 4x minus 1. Again, the top degree is 3, the bottom is 2. It's bigger on top. So none, you don't have one. Okay? There's a difference between 0 and none. 0 is y equals 0, and that's the x-axis. None means there isn't one. Okay. So there's a third case scenario. What's that? Yeah, what if they're the same? Very good. So each DC is exponents are the same, divide coefficients. That would be your leading coefficients. If exponents are the same, you divide coefficients. Okay. So example, if I had 4x squared plus 5x minus 1 over 3x squared minus 2. See how my degrees are the same? They're both 2. So my leading coefficient on top is what? 4. My leading coefficient on the bottom is 3. Therefore, my horizontal asymptote would be 4/3. You just divide the leading coefficients. And then the range, right, after you know horizontal asymptote, the range, just like the x, whatever the horizontal asymptote is, the range is not. So your notes for range would be y cannot be the horizontal asymptote. Okay, so let's throw all of those steps together and try an example. So, of course, the first step then is to factor. I look in this first example, is there anything to factor? No, you can't factor anything, so that's done. So let's move on to vertical asymptote. How do I find vertical asymptote? You set the bottom equal to 0. What's going to make this undefined? What plus 6 would give me 0? -6. There's my vertical asymptote. Did anything cancel out, cross off? No, so there's no holes. I don't have to worry about that. Okay, so then I can worry about domain. Domain x can't be what? -6 because there's an asymptote there. Then I can do x-intercept and y-intercept. X-intercept is what? How do I find x-intercept? You set the top equal to 0. Can I make 5 equal 0? Is that possible? No, there's no x to work with. So this is none. If you can't set the top equal to 0 with an x value, it's none. Y-intercept means I put 0 in for x and solve. So I put a 0 in for x here. What's 5 divided by 0 plus 6? 5/6. So my y-intercept would be 5/6. Okay. And then here's the new part. My horizontal asymptote is what? The degree on bottom is bigger, because this is 0 and this is a 1. So if it's bigger on bottom, it's 0. And then my range, if my horizontal asymptote is 0, my range y cannot be 0. All right, and then to graph, graphing is fairly simple. All I want you to do is sketch in your information. So I put in a vertical asymptote of -6. Sorry.
You had this over.
Y-intercept of 5/6, horizontal asymptote of 0. And if you graph this on a graphing calculator, you should be able to just sketch in this graph using your asymptotes and any intercepts that you have. I need to make sure I go through that y-intercept when I graph it. And that's all I want. Just graph it on graphing calculator and just kind of sketch the picture that you see. Just so you can start visualizing what these look like. So again, my first step is to factor. Is there anything to factor in this problem? I can factor the bottom. What can I factor out? A 2. Yep. I can factor out a 2. Right? And that's not factorable, so I'm done. That's all I can really do. Okay. First step is to find my vertical asymptote or any holes. I notice there's nothing to cross off, so there's no holes. So I can find the vertical asymptote by doing what? Set the bottom equal to 0. Okay? So some of you might be able to do this in your head. What number squared would give me 2? So I'd have 2 minus 2 is 0. If you can't do that in your head, you would have to set it equal to 0 and use your algebra skills to find what x would be. So I would add 2 to both sides. How do I get rid of a squared? Square root both sides. So I'd have this. I'm actually going to have 2 vertical asymptotes, positive root 2 and negative root 2. So I'd have x equals plus or minus square root 2. And that should make sense if I put square root of 2 in here. Square root of 2 squared is 2, and 2 minus 2 then would be 0. Okay. Therefore, my domain, x cannot be plus or minus the square root of 2, because that's where my asymptotes are. X-intercept is what? How do I find x-intercept? You set the top equal to 0. What plus 2 gives me 0? Negative 2. Y-intercept, how do I find a y-intercept? You put 0 in for x. What happens if I put 0 in for x and solve? What do I get? 2 divided by negative 4, which would be a negative 1/2. Right? 0 plus 2 is 2. 2 times 0 squared is 0. 0 minus 4 is negative 4. And that's negative 1/2. Simplifies. You put 0 in for x and solve it. You only put it into, oh, you could, yeah, it'd be the same thing. And then my horizontal asymptote is what? Is it bigger on top or bigger on bottom or the same? The bottom is bigger, so 0. And then range, if my horizontal asymptote is 0, then y cannot be 0.
Wait, wouldn't that be none instead of 0?
Sketch in your asymptotes. What is the square root of 2 as a decimal? 1.7? So just do the best you can. 1.4. So I will graph a positive 1.4 and a negative 1.4. Okay, and this is why I want you to be graphing these, because this is how goofy they start looking. And then I have a horizontal asymptote at 0 and an x-intercept at negative 2. A y-intercept at negative half, okay, and a horizontal asymptote at 0, but what's going to happen is that horizontal asymptote isn't going to go all the way through. So if you graph this on a graphing calculator, you get this kind of curved thing like this. So if you just use your graphing calculator and just sketch in, it doesn't have to be exact, but it's going to look something like that because we have more than one asymptote. All right, first step, factors. Anything to factor? No. So let's look at holes in vertical asymptotes. I can't cancel out those x's. Don't do that. You can't cross off those x's. They're part of polynomials. So there's nothing to cross off, so let's look for vertical asymptote. How do I find a vertical asymptote? You set the bottom equal to 0. What plus 5 gives me 0?
Negative 5.
If my vertical asymptote is negative 5, what's my domain?
Not negative 5.
X cannot be negative 5. Very good. My x-intercept would be, you set the top equal to 0, so what plus 1 gives me 0? Negative 1. My y-intercept would be, you put 0 in for x, 1/5. Very good. My horizontal asymptote would be, they're the same degree, so I
1/5.
divide the leading coefficients, which are 1s. 1 divided by 1 is 1. Therefore, not my domain, my range, y cannot be 1. Easy. So put in your vertical asymptote, 1, 2, 3, 4, 5. Put in your x-intercept, negative 1. Put in your y-intercept, 1/5. Put in your horizontal asymptote of 1. And then what it looks like, if you graphed on a graphing calculator, it looks something like that. All right, so look at this one. Is there anything to factor?
Yes. No.
No, they're not. Neither of these quadrics are factorable. Actually, they're not. So I'm good to go. Okay. So nothing's gonna cross off. You cannot cross off those x squareds. Don't do that. So there are no holes. Okay. So let's find a vertical asymptote. Vertical asymptote is when I do what? Set the bottom equal to 0. So what x value squared times 2 and then subtract 1 is going to give me 0. Okay, so let's use some algebra skills here. Okay, so 2x squared minus 1 equals 0. We're going to add 1. divide by 2, and then what? Square root both sides, but this is ugly. You do not have plus or minus square root 1/2. How do we fix that? We square root the top, square root the bottom,
Is there problems like this on
but we cannot have a square root of 2 on the
This is so
bottom.
annoying.
So we
I forgot how to do this.
multiply top and bottom times square root of 2,
I'm giving up.
and we'd get plus or minus root 2 over 2. That's what it should look like, not plus or minus
That
1/2.
looks ugly.
Right?
too.
Square root of 1/2 is not how we write that in mathematics. We write it like this. We fix the denominator.
Well, I'd rather have
And
a
have it
square
go
root of
like
1/2
that.
than
So we'd have plus or minus square root 2 over 2. Those are my vertical asymptotes.
if we're going off the looks, I think the square root of 1/2.
So if my vertical asymptotes are plus or minus root 2 over 2, what's my domain?
Not.
X cannot be plus or minus root 2 over 2. Very good. Okay, what about x-intercept? What's my rule for x-intercept? You set the top equal to 0. What x value is going to make the top 0?
None.
If I didn't see it was none, you would start solving it. And last lesson I told you, if you ever get to a point where you're going to square root a negative number, you stop. That means it does not exist. So x-intercept is actually going to be none. There's nothing you can square, add 2 to it, and get 0. It's impossible, unless it's an imaginary number.
Like A.
What about y-intercept?
Set X to 0.
You set x to 0 and solve. What do we get? Top becomes 2. The bottom becomes negative 1. So my y-intercept is negative 2. What's my horizontal asymptote? The degrees are the same. Exponents are the same.
1/2.
So I divide the leading coefficients. 1 divided by 2 is 1/2. Therefore, my range y cannot be 1/2. Right? Now, in order to sketch this in, we do need to know what square root of 2 divided by 2 is.
Hold on.
What's that? Point.
Or you can just put in the calculator.
That's what I'm doing.
You can put in horizontal asymptote of 1/2.
Wait, no.
What do you say?
We can put in a y-intercept of negative 2.
It's 0.7.
0.7?
Yeah.
So square root of 2 over 2 is 0.7, so we would graph a positive 0.7 and a negative 0.7. And again, when you look at this picture on the graph, you should see it looks like this. It goes up, and then this one, and then this one, it kind of curves up, touches that intercept, and comes down.
You broke it.
I know my marker's off. So just by knowing the asymptotes and the intercepts, you should be able to look at your graphing calculator and just sketch the graph.
But that was a really.
So first step, of course, is to do what? Factor. And how can I factor the top?
Taking X out.
I can take an x out. Very good. I can take an x out and I get 5x squared plus 2. What can I do to the bottom?
Take 3 X's out.
3, right, they both
And
have
2.
a 2 and 3 x's. Very good. Okay. And then nothing else I can factor. These quadratics that are left, I can't factor those. Okay. So let's start looking at stuff. You should notice when you factored these, there's something that cancels out. Something creates a hole. Do you see it?
Plus and minus 2. Wait.
X squared.
I can cross off one of these x's.
Why?
Okay, if I wrote this out, this 2x cubed out, right? I would have 2 and 3 x's, right? 2x cubed. This x is going to cancel off with this x.
Why can't you do that with the other ones then?
because now this is multiplying,
Is that
right?
not
I'm not adding or subtracting anything to that x. That's a polynomial by itself. So I can cross those off. Therefore, my step 1 here, I'm going to have a whole at 0. Because I set that equal to 0 and x is 0.
set what equal to 0?
Oh, I love that.
Get the whole identified. I'm still going to have an asymptote. What's my asymptote? This is very similar to one we had before. What number do I square to equal 2 so I can subtract 2 and get 0? You don't remember? We just had it 5 minutes ago.
Plus or minus root 2 over
Very
2.
good. Because I would add 2, right? Square root both sides.
Yep, got it, Chapman.
So I'd have plus or minus square root 2. So I have a lot of things here that can make the denominator 0. I can have 0, and then I can have plus or minus square root 2.
Okay.
So therefore, my domain, x cannot be what?
Plus or minus 0.
0 and plus or minus square root 2. What about x-intercept? X-intercept, I set the top equal to 0. Can I square a number and multiply by 5 and add 2 and get 0? No. That's impossible. If you didn't see that, again, what do? You just solve it. Subtract 2, divide by 5. And then I would square root, and as soon as you start square rooting this negative, you'd stop and say, oh, there isn't one. So none. What about y-intercept? Y-intercept, you're going to put 0 in for x. What happens if I put 0 in for x and solve it?
Oh, there's more. There's more.
If I still have x's out here that I'm multiplying. If I put 0 in for these x's, the denominator becomes 0. Can you ever divide by 0? No, so none.
Oh my god.
Horizontal asymptote would be what?
Let's look here.
The bottom is bigger because even though I factored out these two x's, this is still an x to the 4th power on the bottom.
0.
The bottom is still bigger. So bigger on bottom, 0. Therefore, my range, y cannot be 0. Very good.
That's lame.
You can put in your vertical asymptotes. We had that before. It was like 1.4, right? And a whole at 0. We'll get that one in. Horizontal asymptote.
Oopie, I did this wrong.
No intercepts.
Is the
And you
ball-
graph it. What did you guys notice when you graphed it?
Actually, I need
No, I didn't graph
Did
it.
you guys notice when we graphed it, we actually missed a vertical asymptote?
Yeah, I noticed
Because if you set the bottom equal to 0, square root of 2, but I also have these x's.
Whoa.
So you have a whole at 0, but there's also a vertical asymptote there because of the,
If I come across this kind of
because there's
problem,
still
I'm gonna
x's
score.
there.
why though?
Okay? So there's actually a vertical asymptote here. So then when I graph it, you should see how crazy it looks. You have these like two curves
Oh
here,
my god.
like that.